What is taphonomic bias in fossil formation? Imagine trying to piece together a puzzle with missing pieces. That's what studying fossils can feel like because of taphonomic bias. It's a term that explains why some parts of the past are more visible than others in the fossil record. When animals or plants die, their remains don't always turn into fossils. Many factors influence what gets preserved and what doesn't. This means the fossils we find are often just a small, skewed sample of all the life that once existed. In biological anthropology and paleoanthropology, understanding this bias is key. It helps scientists avoid jumping to false conclusions about ancient humans or animals. For example, bones with hard parts like skulls or limb bones are much more likely to fossilize. Soft tissues like muscles, skin, or organs decay quickly and rarely leave behind fossils. So, the fossil record tends to overrepresent creatures with sturdy skeletons and underrepresent soft-bodied organisms. This can make it seem like certain species were more common or diverse than they really were. Environmental conditions also play a big role. Rapid burial in sediment like riverbeds or lake bottoms helps preserve remains. If an organism dies in a dry or exposed environment, it's less likely to fossilize. Chemical factors, such as mineral-rich waters, can also influence preservation. After death, remains can be scattered or damaged by scavengers, weather, or water currents. These post-mortem processes can break bones apart or move them from their original location. This means some bones are more likely to be found than others, skewing the record further. Time averaging is another factor. Sediments often accumulate over long periods, mixing remains from different times. This can create the illusion that species lived together when they did not. It can also inflate the number of species in a site, making it seem more diverse than it was. Plus, the chance of discovering fossils depends on where and how they are buried. Some fossils stay hidden deep underground or are eroded away over time. Others are easier to find because they are exposed on the surface or in accessible locations. In paleoanthropology, recognizing these biases helps scientists interpret fossil evidence more accurately. It's important to understand which bones or species are likely underrepresented. This knowledge guides researchers in reconstructing early human environments and behaviors. For example, if certain bones are missing, it might be because they didn't fossilize well, not because those bones were never part of the original population. Overall, taphonomic bias explains why the fossil record isn't a perfect mirror of past life. It's a reminder that what we find is shaped by natural processes that favor some remains over others. By studying how fossils from and are preserved, scientists can better understand what the record truly tells us about the history of life on Earth.